All right, welcome back to pre-calculus. Give me a moment here. Sorry about that. Welcome back to pre-calculus. I hope you did not adjust your volume yet. So let's just keep going with us and see how far we can go. Okay, so let's see here. We have 17. Like, that doesn't look like a complex number. Okay, but it is. Okay, so we have 17. Where is 17? 17 is there, right? This is the real axis. So what is this angle? This angle is 0. What's the length? 17. So this is like tricky in a way because it's too easy. Okay, but if I always put this in polar form, this is going to be 17 cosine of 0 or 2 pi plus I sine of 0. Okay, so that would be our polar form here. So this is 17. Okay, parentheses. Oops. Parentheses, and this is just going to be cosine of 0 plus I sine of 0. And I think we're just going to call it a day there. I'm hoping this works out. Okay, it took the answer. This is negative 13i. We're going to be dealing with the same thing, same type of thing. So where's negative 13i? Well, that's down here somewhere. Okay, so here's negative 13, right? And this is again in the imaginary plane. And how do I get down here? Well, I could either say it's negative 13 times the sine of pi or positive 13. I think you're going to want that instead because r is usually a positive number. And we have cosine 3 pi over 2, right? Cosine of 3 pi over 2 is 0 plus I sine of 3 pi over 2. Okay, and that's what they're going to want for this. Okay, so make sure our 13 here is positive, parentheses, and I want a cosine of, what do we have? We have 3 pi over 2. Okay, plus I sine, and we're going to have 3 pi over 2. And we'll chalk that up to a win here. Okay, and again, okay, I'll tell you, you have to put pen to paper. I mean, it seems like, well, I'm just going to follow what you're doing and that's it. Like, you are not going to learn this. This has to be, you have to do like, show me another answer so I can do something a little bit different. And then you have to walk through it yourself. Like, your hands have to grip the pen and you have to write this stuff down. Otherwise, you're not going to get it. Okay. So really take the time to write it down and, practice doing the homework, practice doing these problems, because that's how you're going to get it. Okay. A couple of years ago, me and a friend would go to a gymnastics gym, and she did it as a child, so she could get on a balance beam and do a cartwheel, which to me is like a superhuman event. I could watch her do that from now until I die of old age, hopefully. I would never be able to do it. Okay. There's a lot of issues. Okay, we know, but it's just not something that I'm capable of doing. I can get close and try it, preferably on a very small balance beam, but like I can do a cartwheel. Okay, that's pretty good. I mean, don't get me wrong. It's a clown cartwheel. It's not like a nice looking one. Okay, it's the kind you see a drunk clown do. That's the kind of cartwheel I can do. But I have to practice the cartwheels in order to get into a straight line to even have a chance of doing what she does. So even though it's like, well, I could do that, I could watch somebody do it. It's like, it's not good enough. You got to practice this stuff. Okay, so I'm begging you, practice it. Okay, so this is convert the polar coordinate into Cartesian, right, to a rectangular form. So this was 12, and we have cosine of 3 pi over 2 plus 3 pi over 4 plus I sine 3 pi over 4. Where the heck is 3 pi over 4? Well, here's 2 pi over 4. 3 pi over 4 is going to be here. Okay, so it's in quadrant 2. This is 3 pi over 4. And the reference angle for 3 pi over 4 is 1 pi over 4. Okay, Because how much more do we have to go to get to a horizontal here? That's pi over 4. That's my reference angle, pi over 4. So what's the sine of pi over 4? That's square root of 2 over 2. And the cosine of pi over 4 is square root of 2 over 2. Okay, one hopes you would know that by now, but I understand. Not everybody's going to know. I would just hope they would. Okay, but I'm not going to shame you in person for doing that either. If you don't know, I'm just going to, you have a calculator, you can use that. Okay, but we're not going to have cosines anymore. We're just going to have square root of 2's over 2's. Okay, so when I take the cosine of 3 pi over 4, we're going to get square root of 2 over 2. It's in the second quadrant, so this has got to be a negative value. Okay, because cosines are negative in the second quadrant. Okay, plus I, now sine of sine of pi over 4, right? That's again, it's pi over square root of 2 over 2. But look where it is, right? The y part is going up, so that's still positive. Okay, so sine is positive in the second quadrant. Okay, and we just multiply this thing by 12, so we're just going to get negative 6 square root of 2, right? 2 divided 12 over 2 is 6, right? Plus I, and then we come over here and we get positive 6 square roots of 2. And that's going to be my answer for this number in rectangular coordinates. Okay. So what do we have? We have negative 6 root 2 plus I sine plus I, or 6I square root of 2. Okay, and that's what we're going to want here. It didn't like it. What did I not do? Give an exact answer. I did. Oh, I said negative, and then I went and pressed positive. So of course it's wrong. Really helped to put the right numbers in. Okay, there we go. So I'm glad they gave me 3 chances. All right. So yeah, we could do this with, instead of radians, we could do it with degrees. Okay, what is this? Convert this to polar form to rectangular form. So we have root 5. Okay, we've got cosine of 180 degrees plus I sine of 180 degrees. Where is that? It's right here, isn't it? So it's 5 at 180 degrees, root 5 at 180 degrees. So this is just going to be negative 1. Okay, this cosine of 180 degrees is negative 1. So we have negative root 5. And then sine of 180 degrees, that's 0. So we don't have an imaginary part this time, just this guy here. So this is negative 5, negative square root of 5. So minus square root of 5. We'll call that good. Right? They only wanted 1 at a time. Whatever. Okay. Use de Moivre's theorem. I always love this one. To find the indicated power, write the rectangular form of it, and then we'll be done. Okay. So de Moivre's theorem, and you'll be in my class, you're going to be provided that de Moivre's theorem is r to the n cosine to the n theta plus I sine to the n theta from what the z to the n is. Okay. So all we're going to do is we're going to plug this 3 in, and we're just going to say, well, that's going to be 3 cubed, or 4 cubed rather. So that's 4 cubed for this 4 here. And we're going to have cosine of 3 times 4 pi over 9. I'm really sorry about that. Plus I sine of 4 pi over 3 times 4 pi over 9. Okay, 4 cubed is 64. So we have cosine rather of 3 over 9 is going to be 1/3 left over, right? So it's going to be 4/3 pi. Okay, plus, we'll go ahead and do this. It's a terrible notation, by the way. I sine 3 over 9, and that's going to be 4 pi over 3 By the way, if you don't get the same angles here, because the shorthand for this is CIS, cosine theta plus I sine theta, and they only give it one angle. So these angles have to be the same. Okay, otherwise this notation wouldn't make any sense. Okay, so 64, what is the cosine, right? Where is cosine? What is 4 pi over 3? Right? This is 2, 3 pi over 3. Oh no, this is 2 pi over 3, 3 pi over 3. This is 4 pi over 3. It's down here. And it's 4 pi over 3. What's the reference angle? Reference angle is pi over 3. Okay, or 60 degrees. Okay, so the cosine, right? Look at what the cosine does. Cosine starts up here, gets kind of small. So by the time it's hitting pi over 2, it's at 0. So here we go. So that's just going to be 1/2. It's in quadrant 3, so it's negative. Okay, plus I, and then we have the same deal. Okay, with sine 4 pi over 3. Well, what's sine do? Sine does something like this up here. So this is pi over 2. It's almost right next to it. So we're getting bigger and bigger and bigger. This is the square root of 3 over 2. Okay, and again, third quadrant, this is going to be negative. Okay, so 64 times half is at 32. Okay, and then minus, because of the whole third quadrant thing, this is going to be 64 over 2, right, which is 32. Okay, square root of 3. I. Okay, and that's where we are with this. So this is going to be negative 32. Okay, minus 32 square root of 3. And I. Okay, and that should do it. All right. Let's see what else we have. That's the same problem. That is nearly the same problem. And then here's a problem that I would have been tempted to put on your quiz. Okay. So something like this. And again, you do not have to memorize de Moivre's theorem. I will write that down on your quiz for you. You get to look at it. It's the same one you're going to see in your book. Okay. So what's going to happen is we're going to do de Moivre's theorem. So I'm going to want, right, here's the square root of 3 over here. Here's negative 1. So this is square root of 3 minus I. Now we have to raise to the 5th power. Okay. How to raise to the 5th power. So we have to know how long this thing is, right? So we're going to find the modulus. So the modulus of the length of the absolute value, okay, it's going to be the square root. It's the hypotenuse of this triangle. See, we just drew another little triangle. It's the hypotenuse. How do we get the hypotenuse? Well, we're going to say the square root of 3 squared minus negative 1 squared. That's going to be 3, right? Square root of 3 squared is 3. Negative 1 squared is going to be positive 1. Still have this outside square root here. So 3 plus 1 is 4. And that's going to be 2. We want principal square root. Okay. We know where it is. We know where the angle is going to be is negative something here. Okay. How do I get this angle? Right. We have an opposite. We have an adjacent. What trigonometric ratio relates opposite and adjacent? Well, tangent of theta equals the opposite over the adjacent, doesn't it? So we have tangent of theta is equal to the opposite, negative 1, over the adjacent, square root of 3. This is another one you should know. Okay, 1 over root 3, this is going to be pi over 6. It's down here, so what's the pi over 6 that's in the 4th quadrant? That's going to be 11 pi, you can never write 11 pi, divided by 6. Okay, so theta, right, the angle is equal to the tangent of 1 square root of 3. So the tangent is equal to 11 pi over 6. Okay. So when I go to put this back in, right, I want to raise this thing to the 5th power, right? This is going to be r to the 5, right, times cosine of 5 times, what was the angle? 11 pi over 6 plus I sine of 11 pi over 6, right, times 5. All right, so this is, what do we have here? We had our modulus being 2. So we have 2 to the 5th. Okay, now where the heck, right? 5 times 11, this is 55 pi over 6, isn't it? Well, how many times around can we go with that, right? So if we go one time around, that's 2 pi, right? Or 12 pi over 6. If you go around again, that's 24 pi over 6. If we go again, right, that's going to be 36 pi over 6. And we go around once again. So this is the 4th time around, right? We're going to be here at 48 pi over 6. Right? Now 55 pi, I've got to get to 55 pi. 48 pi plus what equals 55 pi? And I think we could say this is going to be 7 pi more. So we go around 4 pi, now we need to go around 7 pi more, and we're going to be right there. Okay? Now you say, oh, I can't be expected to do that. That's way too hard. When I plugged this into the calculator, I got negative pi over 6. Like you sure did, because you've got the first original angle was this one. Okay? So that's what you could do here. That's what inverse tangent will tell you. And then we're going to multiply it by 5. So we're going to have negative 5 pi over 6. Where is negative 5 pi over 6? Right there. Right? It's 1 pi less than to pi 6 pi over 6. Okay? If we go around in the clockwise direction. Well, where is, right? We have this. Where is 7 pi over 6? Well, 7 pi over 6 is that one right there. Oh, you get it right, regardless of which direction you go. Now that's a good, I like that as an answer, because that means, oh, do I have to pick left or right? It doesn't matter. Pick one, they'll be right. Right? So you like problems where it's like, it didn't matter which technique you applied to the problem to get the answer, you still get the right answer. Like that's a strong way of doing something. Okay, so here it is. It's still 7 pi over 6. It's third quadrant. Okay, what is the cosine, right, of 7 pi over 6? Okay, we'll say negative 7 pi over 6 instead of 55 pi over 6, but it wouldn't matter. Plus I sine negative 7 pi over 6. If you wanted to replace this by 55 pi over 6, we're still talking about the same angle. Okay, so there we go. So third quadrant stuff. So this is 32, right? This is 32. And then we have cosine of 7 pi over 6. So it's going to be negative, right? And again, cosine, by the time we get to a reference angle that's like 0.6, it's going to be over here. So this is 1/2. Plus, well, not plus, minus a negative, right? Because it's still going to be negative because it's over here. And we have sine of pi over 6. Well, that's going to be, oh, I'm sorry, this is wrong. I should have known that. That's 3 pi over 2. Square root of 3 over 2, rather. This is a square root of 3 over 2. This one is 1/2. Right? So we go ahead and do that. We're going to get 16 root 3, negative, of course, minus 16, right? 16 times 16 is 30, or 16 times 2 is 32. It's 16i, right? And that's going to be our complex number back into, right, Cartesian format. Okay, so this is going to be negative 16 square root of 3, all right, minus 16i. And that should do it for us. Right? Is this pretty much asks you everything you would ever want to ask you about complex numbers? So if I'm going to ask you a problem, it's going to look something like this. Okay. Now again, you don't have to memorize de Moivre's theorem, but given something like this, you have to know, like, well, how do I figure out the length? How do I figure out the angle? Notice on almost every case, every time we did a complex number, we always drew a triangle so we could see what we were looking for, what the angles were, and where we were on the coordinate system to get our positives and negatives in the correct way. So complex numbers, they might look a little scary, and I get they can, okay? But at this point, we're just dipping our big toe into the water to see how it feels. And if you're like, this feels unfamiliar, you can always graph it, draw a triangle, and now you're back in familiar waters, and it shouldn't be a problem, okay? So just make sure you can practice doing graphing these things, because that was the first part of the chapter, but that was really important, all right? And then from the triangle, it's like, hey, can I get the angle? Can I get the hypotenuse? Can I do some things with this triangle? The answer is going to be yes. You've been doing trigonometry for quite some time now. You're good at this. Don't talk yourself out of it. All right. So best of luck with this stuff. Like I said, practice number 12 a lot. All right. Or practice the steps up to level number 12, which is going to be some of these. You don't have to do them all, but do like every third one or something like that. And then tomorrow do another every third one. Okay, just not the same ones. Do the other parts that you missed. Okay. But if you want to practice number 12, like 3 days or so, you want to do that every day, that's fine. Okay, because that's what I'm going to ask you. All right. Good luck, and I'll see you on the next video.